Dear student, in this video we will discuss some more examples of PDA. So example is that we are asked to design a PDA which will accept a set of all strings over input alphabet A and B, where number of A is equal to number of B. They can be intermerged, they can be intermingled. That is, there is no boundation. That it does not mean that if this question is equal to A power n, B power n. This is a different question. Here the number of A is equal to number of B. That's it. Where A and B can be merged also. So we are asked to design a PDA which can accept all kind of those strings, and we are asked to design PDA which can accept this language with the help of final state and with the help of empty stack. As you already know that PDA can accept strings, PDA can accept language by two ways. One is the final state and another is by empty stack, right? So first of all we have to make it logic, and logic is that suppose we are having A and initial stack top symbol is the stack initial symbol, so we will push A on that, and if A is on the top of the stack, again A appears, so we'll again push A on the stack. Now suppose stack top symbol is the stack initial symbol and B appears, so we will push B on the stack, and suppose B is the input symbol and on the top of the stack B is there, so we will again push B on the stack. Now suppose if we input A in the input tape and B is on the top of the stack, so we will cancel that one, we will consume, we will read that symbol from the input tape and we will pop that element from the stack also. And for vice versa case also, suppose we recently read B and suppose there is A on the top of the stack, so we will pop A element from the top of the stack. And by keeping, so if suppose the string has been exhausted and stack top symbol is the stack initial symbol, in that case we will make stack empty. So let us see here. So initial state, and by this way we will be remaining on the same one state, that it doesn't matter ki A is coming after B or B is coming after A. So idea is that we are remaining on the same state, and with the help of only one state we are making its solution. Suppose on Q0 state A is there and the stack top symbol is the stack initial symbol, we are pushing A. Suppose B is input symbol and stack top symbol is the stack initial symbol, then we are pushing B here. Now suppose A is on the top of the stack and the input symbol is A, then we will push A on the stack. Now suppose B is the input symbol and B is on the top of the stack, we push B on the stack. Now suppose we read A and at that time the stack top symbol was B, then they are cancelling. So it means at that time what we will be doing, we will be remaining on the same state and we will pop B. Now suppose we read B and the stack top symbol is A, so we will pop A element at that time. And now suppose the string has been exhausted and the stack top symbol is stack initial symbol, at that time we will make stack empty. By this way we are accepting that string. Now let us solve the same question with the help of final state. So what is happening here? Suppose we are initially we are on the Q0 state and A is the input symbol, at that time Z0 was the stack top symbol, so we are pushing A. Or B is the input symbol, is initially stack top symbol was the stack initial symbol, we are pushing B. If input symbol is A and stack top symbol is A, we are pushing A. If input symbol is B and stack top symbol is B, we are pushing B also. Now if A is input symbol and B is on the top of the stack, we are cancelling them and we are popping B. Now suppose B is the input symbol and A is on the top of the stack, we are also popping A. Now suppose the string has been exhausted and stack top symbol is Z0, so what we are doing, we are leaving that symbol as it is and we are moving to one another state, that is the final state. So here we are moving to the final state. So by this way we have make the PDA by both the ways. Now there is one very important, very beautiful example which we are covering in this lecture, and that is construct a PDA for the following language, and the language is the set of string over AB with exactly twice as many A's as B. That means number of A's are double. Here, in each string of the language, number of A's are double. So it's a very good example. So what we will be doing, first of all, we have to make its logic, and the logic is that for each one pair of A, question is number of A is double. Suppose there are 4A, so B must be 2. Suppose there are 10A, so B must be 5, and they are merged. They are not ordered. They are merged themselves, and the condition is that number of A is twice the number of B. If there are 100A, so number of B must be 50. So here we have to make its logic, and logic is that for each 2P, we will push 1 X on the stack. For 2P, we will push 1 X on the stack, and for 1B, we will push 1 Y on the stack, and the vice versa for cancelling, for popping the element, right? So let us see here how we are writing the transitions. First of all, I am showing you the transitions. Suppose we are on the initial state, that is Q0 state, and the initial symbol can be A, initial symbol can be B also. Sorry, input symbol can be A and the input symbol can be B also. Now let us see, suppose stack top symbol is Z0, at that time input can be A, at that time input can be B also. See here, when the machine is on Q0 state and the stack top symbol is Z0, suppose the stack top symbol is Z0, so at that time machine can read A from the input tape, or machine can read B from input tape. It can be anything. So if A is there on the input tape, so we are not doing anything. We are simply shifting to one another state, that is Q1 state, and we are doing no operation. So as I previously told you that for 2A, we will push 1 X on the stack. So here only one A has been encountered, so we are not pushing anything. We are simply shifting to one another state. This Q1 state itself represents that one A has already been encountered, and for that A we have done nothing. Now suppose Z0 is the initial the initial stack symbol is the stack top symbol, and B is the input symbol. Then at that time we are pushing Y on the stack. We are pushing Y on the stack, and we are remaining on the same state. Now suppose machine is on Q0 state and the input symbol is A and the stack top symbol is X. Stack top symbol is X. This X means for 2 A's 1 X has been pushed on the stack. Suppose this is a scenario and machine is on Q0 state. Again we are doing nothing. We are simply changing the state. We are changing the state and we are doing no operation. X1 itself indicate that 1 A has been encountered, and for this A we have done nothing. It is the pending job. Now suppose if machine is on Q0 state and A appears and the stack top symbol is Y. Again what we are doing, for 1A we are doing nothing. Suppose we are on Q0 state and A appears, we are doing nothing. We are simply shifting to one another state, that is Q1 state, and Q1 state itself represent that we have done nothing for 1A. So that job has been pending. So we did nothing, we perform no operation. Now suppose machine is on Q0 state and B is encountered and the stack top symbol was X. The stack top symbol was X. It means that for 2A 1 X has been pushed onto the stack, and now B has encountered. So this B will cancel this A. So we are remaining on the same state and we are popping X. Right. Now suppose Q0 is the initial state, B is the input symbol, and Y is the stack top symbol. So what we are doing, we have to push Y again. So that is, we are remaining on the same state and pushing Y. Now see here, there are 6 transitions. 6 transition means input symbol can be A or B, but stack top symbol can be Z0, stack top symbol can be X, stack top symbol can be Y. So by this way there are 6 transitions. Stack top symbol is A, sorry, stack symbol top symbol is Z0, input is A. Stack top symbol is X, input is A. Stack top symbol is Y, input is A. Similarly, stack top symbol is Z0, input is B. Stack top symbol is X, input is B. Stack top symbol is Y, input is B. By this way there are 6 operations. Now suppose we are on Q1 state. Q1 state means that there is some pending job. There is some pending job. Now A appears and the stack top symbol is Z0. So what it means? That there was a pending job, another A is appeared now. So we are again moving back to Q0 state, indicating that there is no pending job left, and now for this new A we are pushing 1x on Z0. So the earlier job has also been compensated here. So Q1 indicates that there was some pending job left behind. Now again A is coming, so now it means now there are 2 A's. For 2A we are pushing 1x onto the stack. Now suppose again we are on Q1 state, A again appears and the stack top symbol was X. So now X is again pushed onto the stack. Machine is on Q1 state, again A appears and on the top of the stack is Y. So what is happening here? This Y is for B and this A is the second A. So we are moving to Q0 state and we are cancelling it. So it is Y has been popped, right? Now suppose we are on Q1 state and the stack symbol is, sorry, input symbol is B, stack top symbol is Z0, we are pushing Y, stack top symbol is X and it is B. So it means what we have to do, this will cancel them out. So what we are doing, we are popping it, stack top symbol is Y, B is the input symbol, we are again pushing Y. Now on Q0, so this another 6 transitions have been done here. Suppose machine is on Q0 state, input can be A or B, stack top symbol can be Z0, X or Y. So there are more 6 transitions are this. Now suppose we are on the Q0 state, and the input string has been exhausted. Please keep remember this thing, it is very important that on only Q0 state string should be exhausted. String cannot be exhausted on Q1 state, because on Q1 there is some pending job and that pending job has been finished once you approach to the Q0 state. So it means transition, we are writing only this transition, that is machine is on Q0 state and string has been exhausted, and initial stack initial symbol is the stack top symbol. What we are doing, we are moving to another state, that is Q2 state, and we are performing no operation. This Q2 state must be the final state. So let us see its diagram. There are 2 states, Q1 state, Q2 state, and the final state Q0 state, Q1 state, and the final state is Q2 state. Here if B is the input symbol, so we are remaining on the same state. If A is the input symbol, so we are shifting to the Q1 state. For B input symbol, we are pushing Y. Here X was there, so we are popping. If the top symbol was Y, we are pushing Y. For A, we are moving to another state. Now here, if B is coming, we are remaining on the same state, and if A appears, we are coming back to the Q0 state, and here only the string can exhaust, and once the string is exhausted and stack top symbol is Z0, then we are doing no operation and we are finally coming to the final state. So by this way we are accepting these kind of string. That's all about this example. Keep watching next video. Thank you very much.